Hi everyone. Welcome to my MyWebUniversity free education videos and the series of Linux how-tos. Today I'm going to present you video number 7 and let's get started. So I'm going to just show you the PowerPoint Linux how-to. On video number 7 we're going to introduce you the kernel and shells. Without further ado, let me just go through a slideshow on this one. We already covered on video number 1 how to power on the Linux operating system, whether it's Red Hat or Linux Ubuntu, how to get the OS version, how to log out, and how to power off. And then on video number 2, we installed the Rocky Linux version as a virtual machine. And on video number 3, we talked about the graphical user interface of Linux Rocky, as well as Ubuntu, as well as Red Hat. And similarly, we also, on video number 4, we discussed the terminal interface, which is command line interface. And video number 5, we discussed hostname details, which is all the information about the hostname. And then video number 6 was user accounts and group details. In that video, we discussed everything about users, profile, how to create account on the users, and how to set up groups, how to modify users, shells, and so on. And then video number 7, which is today's topic, we're going to discuss the Linux architecture, the kernel, as well as the shells that are the interface for the users to talk to the kernel. The kernel is the core part of the operating system, which basically interface between the shells and the user's environment. From the shells, the kernel gets a request from the user, and then it talks to the hardware to assembly code and device drivers and other ones. So, and some other videos I'm going to discuss, for example, on video number 8, file system of Linux, and then video number 9, we're going to discuss the package manager. So a lot of these videos are going to come next. At this time, we're going to just discuss video number 7, which I have already prepared for you here on a PowerPoint presentation, as well as LibreOffice Impress kernel architecture. On a previous video, I have already discussed the Linux system architecture and details. You're welcome to just go on my YouTube channel and just look for the videos that are related to the kernel. There's a video here about the architecture, so you could just like and make comments and watch it. And then if you haven't subscribed yet, please make sure you subscribe. I really appreciate your subscription, because that way I could just make videos that's going to be more towards your needs. And if you make comments on the videos, that would help me understand your needs, so I make appropriate videos for it. And then so we were discussing the system architecture, that there are videos on the my YouTube channel. Actually, you can just watch it. And then at this time, I'm going to discuss the Linux system architecture. So let me just go with a slideshow from this one also. Slideshow, and then you can see the system architecture of Linux was back in the 90s. 386 architecture was one of the platform that Linus Torvalds actually in 1991 he wrote this kind of email or a note that asked other people to test the software, the kernel that he was building, to find out how good it is, and then maybe they could give some inputs for the kernel, and then see how it was still testing Bash at the time, and then some C and C++, C compiler, not C++ at the time. So back when he was testing it, he found out that there are more people interested in, and obviously that was just an email that went viral at some point, and then Linux was introduced back then. A Linux version of the Unix version was already in back in 1969 by Dennis Ritchie and Ken Thompson at Bell Laboratory. That was introduced, and then now in 1991, Linus Travers introduced the Linux. So the Linux kernel, starting with Red Hat, and there's a lot of different versions that we are using currently. Debian version, Red Hat, and then CentOS is also the community edition enterprise version that was previous to Rocky version that was built in. But let's discuss the kernel first here. We're going to just show you on top of the hardware, the core part of the operating system is the kernel. That's the topic of today's video. The kernel is basically an interface between the hardware and software. And the software that are running on top of the kernels or the shells. So there's the kernel itself that runs on top of the hardware, which is device drivers and daemons. The daemons are like system D in this case on Red Hat, and also Ubuntu version. Previous version to System 5 Release 4 was init. Now it's System D, and then System CTL and Firewall D. All those ones are the kernel daemons. In addition, there are device drivers that talks to the hardware directly on behalf of the kernel. But the kernel has an interface in front of it that is the shells. The shells are basically a way of the user having some sort of command line or interface to talk to the kernel. So the user directly cannot make a request to the hardware. The user send a command or a program, run a program or a compiler or interpreter, utilities or apps or shells, and through the shells they make a request to the kernel. The kernel checks for the access permissions and all kind of security and access control list. And then if the user is granted that kind of privilege or has the rule to do so, then the kernel is going to grant it and then provide the IO input-output from the resources that is available in the hardware. The resources are a list of CPU, central processing unit, memory, random access memory, which is the physical memory, and the input-output, IO input-output, and then display, which is the keyboard, the mouse, the disk, and all the drivers. Everything is storage-wise. They're the hardware. On top of it, then there's software that runs, which is the entire operating system that controls all of these interfaces. As you can see, it's the core part of it, and this circles that I have is the hardware. The hardware has these resources such as CPU, memory, RAM, input, output, IO stuff, and then we have the operating system altogether that has the kernel. The kernel is the core part of operating system, which is made up of device drivers, daemons, assembly language code, and then some binaries and some other software that is around the kernel, which is kind of the shells, for example. The software shells are all interface for the user to just use their favorite shells, whether it's C shell, a Bourne shell, Born Again shell, ZSH shell, or Corn shell, or True C shell. Any of these shells the user uses to interact with the kernel. And then outside of the shells or application that are running, interpreters, for example, Python interpreter, Perl interpreter, Bash interpreter, Corn shell interpreter, awk interpreter, compilers that like C, C++, and other languages, Java compiler, which is bytecode. All of those ones, they could be running on top of the shells. So there's daemons that is inside the kernel that are system D related, the OS related daemons. There's also daemons that could be for database kind of daemons, for application daemons, for client server architecture. Sometimes you have daemons, and you have also for security purpose, you have SSL, TLS, and SSHD, firewall D. All of these ones are firewall D, could also be on the kernel levels. For secure shell D is a utility that runs this. So there's also utility for AS for assembly code that compile the assembly language assembler. And then the loader, when you compile a bytecode or executable, you have to load it into memory. The linker uses the LD. The make is that program or utility that will just make out of source code some executable binary for application. When you build the system, you have to use a make, so you can use the entire application faster. VI and VIM, visual interpreter or visual interpreter, improve is editorial. Similarly, the set or ED used to be the older version of VI, and still they're using set for like one-line command, and then we are using it. awk and NOC, awkward programming languages is very good, and then NOC is the new awk, and then GAwk is the GNU awk programming. The name AWK is the name of the 3 pioneers that was taken from there. grep is stand for global regular expression print, and egrep is stand for extended global regular expression print, and fgrep is fast grep or fixed grep based on a string that you do. The reason that grep comes in is because at some point back in 1969 and 1970, when Dennis Ritchie and Ken Thompson were programming and C programming, the memory was very small. So they introduced enterprise communication or piping. With the piping, you have to give the input of one command as output to the second command, and the second command can just do awk on it, or set on it, or grep or egrep or fgrep, and then based on that one you can filter out a certain information. So instead of reading the entire dictionary, you could read the page or the word that you're looking for. You can grep for certain word, or grep for certain lines, or grep for certain string, or awk it for certain field or something similar with set. The GNU is obviously is a very great utility that they have the GNU C collection compiler and the GNU C ++ connection compiler, which is called G++, and then the GNU C compiler GCC. Obviously, GNU is not Unix. That's what it stands for. It is recursive. And then the database, obviously, there's a lot of databases that you can use. MySQL and Oracle, Sybase and Formex, SQL Cloud. There's a number of them, Ingress, Postgres, and a lot of them. And so we are going to just talk about kernel again, and then the shell. So without further ado, let me just go to the last one. And then the last interface is just the users. So you can see, like, for example, if Bill Gates is using Windows operating system, or even a Linux or Unix operating system, or a Mac, depending what he's using at the time, he's having an interface which is either GUI or command line, and he's either developing or using an application or reading his books online, whatever he does, that is his interest, but he has a connection through that interface of the shells and the terminals and GUIs to and the kernel, and then that's the same thing. Well, and then as Robert developing Linux, and similarly with other users, myself, we all have an interface to the operating system, interacting with the operating system. So if I just make that last slide a little bit bigger, so you can see the last slide, we will be done with this. We discussed the kernel and then the shells. And then we also discussed the utilities, which is one of the topics that I'm going to cover next. But the Linux system architecture, you can see the user comes outside of all the software and operating system. So the user make the request through application, interpreters, compilers, databases, other utilities, and then that request goes to the kernel, either through shell or directly from application to the operating system, kernel, daemons, and device drivers. So, and let's just look at the Linux machine. At this time, I have already booted the Rocky version of Red Hat 9, and then I'm going to log into the interface. Okay, so once I'm logged on here, I'm going to be provided this graphical user interface on Red Hat Linux Rocky version 9. So if it is Rocky Linux 9. So if I just click here and then click on this terminal, I get this interface. But because this is just, I installed ZSH, it says the first time that if you are changing a shell, by default, ZSH comes with Mac, but doesn't come with Rocky or Linux or Red Hat or other ones, because they come by default with Bash, born again shell. Or sometimes on the older version, they would have come with the default shell of SH, and then the SH you can upgrade it to Bash or Corn shell or some C shell or true C shell. And then now Mac comes with ZSH by default. So as you can see here, it says that since you're a ZSH new user, you need to just run either quit or do nothing, or just say you will see this message again, or just create this ZSH RC. And .zshrc is a hidden file. So it says that if I'm having a ZSH shell, then I need to create a run control file for it. If you're using Bash, there will be a .bash RC. If you're using Corn shell, there will be a .ksh RC. If you're using true C shell, it would be a .c .cshrc. So this one, and you can even see here that it provided a command, tell that .zshrc. But because I know that these commands, I'm going to just do a pwd here. And then if I just do nothing here, notice if I exit out, next time I open a terminal again, that message comes up again. So I'm going to just clear my screen and then type in touch and .zshrc. That says that create the file called hidden file .zshrc. In order to see all the files on your system, you type in ls minus la, L meaning listed, A for all, and including the hidden file. And notice there's a .zshrc file. If I just want to see only the .zshrc file, I can see this. And notice the file, because I touched it, is only 0-byte file. So that means that I created that file. If I just now exit out of this one and open another terminal, I don't get that message again, because now my profile has that information. But if I say rm.zshrc, and then I exit out now, and I just open another terminal, it will just read that environment, that script again, then it is going to say that again. So whether I do attach tilde slash .zshrc, or simply just do the touch on the directory, it will do it. So somehow maybe I typed in the touch inaccurate with the tilde. Let me just, oh yeah, I didn't do the full thing. So I say touch dot slash ZSHRC. It should have been .ZSHRC. And now let's see if it opens it again. It should not show up. It did not show up. That's good. So the reason it doesn't show up because it sees this file .ZSHRC. Okay. And then obviously, if I want to put commands there, I put ZSH kind of syntax for the aliases, for all the coloring, everything that I do. But that's not part of this to just cover one shell. I'm going to cover more on other shells as well. So I'm going to show you first the kernel interface. So now you can see I'm logged on as ID-UN. I'm logged on as Wahid there. So I can say get int password and then say $ID-UN, the same command, or I could say get int password Wahid. That both of them tells me that I'm using my shell as Ben ZSH. So Ben ZSH is my shell. I'm going to cover a little bit more on the shell first, since I'm on the ZSH already. And just letting you know that if you installed Rocky version, which is on this case is etc os/release, it is Rocky version 9. As you can see, 9.2 is the release. If you do this one, by default, you don't have ZSH. So if you're running Mac, by default, your shell is ZSH. I modified the shell so I could have it another shell. So when you do this get int command, you can see that it is my shell has been ZSH. I could also say echo $shell to see what shell I'm using. And then if I just look at the file directory called shells here, you can see there's also a file saying that what shells are supported in my operating system. So if I do a more on etc shells, you will see the list of the shells that I already have on this. That means I have the Bourne shell, which sh is going to say user bin sh, and /bin sh, /bin sh is a symbolic link to bash. That means if I run sh Bourne shell, it's going to run the /bin bash. And similarly, if I say file /bin bash, that's running bash itself. That's an executable link format, ELF 64-bit. That is the actual bash born again shell. So bash is not symbolic link to bash because it's a binary itself. But file user bin sh, and then that symbolic link, you can see user bin sh, it is symbolic link to bash. So the one that which ZSH, you can see file user bin ZSH is actually executable file also. ZSH is the binary. And you can see I don't have, let's see if I have through C shell. And I don't have through C shell, which C shell is not there. So if I say cat etc shells, you can see that the list of shells that are available for me are Bourne shell, bash, born again shell, and ZSH shell. So I can become root here and then install through C shell. When I install through C shell, I get a C shell by itself. So I'm going to just through C shell as enhanced version of C shell. So I'm going to do I could do a sudo DNF install through C shell. That will just install it if I just type in my password correctly, which I am doing it now. It's going to install it. Then I say, yeah, go ahead and install through C shell. Now I say which through C shell is going to say that is there, which C shell is there. Cat etc shells. Then and now I have the other shells that are provided or available for me. So if I just look at PS command, my current shell is ZSH. ZSH meaning that that's my shell. If I change it to a C shell, notice that my prompt also changed. My prompt also changed. If I just do a PS, now I'm on this C shell. I just went on top of the ZSH, I went to the CSH, which is C shell. And then if I just run the command, say set the env name is equal, name is Wahid, and then set env age is equal, let's call it 100. I don't care. I hope I make it 100. So this is echo $age and echo $name. Then you can see that it is just name is Wahid, right? So the thing that you want to do is say I want to get to another shell. Let's say I go to through C shell. Now I say PS echo $. Now I'm on the cross ID, this one, which is 8808, which is the true C shell. So that one now echo $name does not have any value. Actually, it came from the previous one. So echo $age is also coming from the previous shell because it's exported, right? So I'm going to just go to born shell, which is sh, and then I say PS. Now notice that echo $, is going to show 8845, which is the born shell, and echo $name is still exported from the previous one. So that environment is still having it age. Let's say make age 50. Set since this is born shell, I have to do export instead of setDNB. Export a name is equal, let's say Wahidullah, and then export age is equal, let's make half of the 100 is 50, and then we say echo, I'm older than 50, so don't worry about that. 50 age, we could do that one, and then you could say that as there. And then now my PS is still there. I'm gonna go to bash. Now notice that echo $name, and then the name now changed to uppercase. I mean Wahidullah full name, and echo $age is also 50. So if I just exit out of this one, and then now my shell is back to this. I could also go to Kernel shell if I have a Kernel shell. Cat etc shells. Kernel shell is there or not? No, it's not there, so I have to install it, which is sudo dnf install Kernel shell. That would install Kernel shell. So every shell, depending on what you want to use, you do it. But normally, if you're on a Linux machine, you prefer either bash or ZSH, but it's your choice. If you prefer Kernel shell or C shell, that the older version and you're used to it, you're welcome to use that as well. So here I'm going to just do which Kernel shell first, and you can see user ben Kernel shell is there. So Kernel shell here, I could get the Kernel shell and echo $and name. It is all there. Echo $age is there. So notice as I change my shell, and now this number, the process points to the previous one. So if I exit out of Kernel shell, I'm falling back to the born shell, which is the sh, and then the process ID of that one is 8845. Similarly, echo $name is still pointing to Wahidullah, and age is pointing to that. Now let's exit out of the born shell, and I'm on back to TCSH, and then echo $$ is the 8808. So if I just say echo $name, notice that from Wahidullah, on that one we had declared Wahid, it just went back to Wahid. And echo ages should be 100. So now it is 100. And then exiting out this one, now I'm on the C shell. Similarly, if I just do echo $name, and then echo $age, and echo $, the process ID is 8069, and then you can see the CSH is 8069. If I exit out of this one, it's going to drop me to this main process that I started, which is get end password Wahid, ZSH, or echo $shell. It is pointing to Ben ZSH. So that is there. If I just exit out of this one, next time I come in, because on the etc password file, my ID-UN is showing me that's Wahid, grep -I Wahid etc password. It is just showing that I'm using Ben ZSH. So every time I log in, it is going to look at my home directory, which is echo $home, as echo $home. I mistyped home, sorry. Echo $home. Oh my God, sorry. Let me clear the screen here. Echo, let's do the grep first. And then we say echo $home. And then you can see it slash home. That means I'm on that directory. Echo $home is pointing to the same one as echo. Let's do a PWD here, or echo $home is the same thing. So if I just go on the default shell, there's a file called zshrc, and then it knows my shell. So it is not prompting me to just create this file, but since it is my environment is Ben ZSHRC, the echo $shell is pointing to the shell that I'm using. So if I want to change that one to a bash, when I do a get env, I'm sorry, get entry, not env, get env, I'm sorry, ent password, and then Wahid. You can see, and instead of Wahid, I could also say backtick ID-UN, and that would do it. Or I could say the subshell, I could use $ID-UN and then run that command. It will do it. But let's do the one thing here. Since we have the ID, I'm going to say, well, let's just change the shell from echo $shell is Ben ZSH for me, which I can see it right here. And let me just do this command. I'm going to say grep -I ZSH. So I marked it in a red color so you can see that it is the shell is that. And I could do the same thing with this command, grep -I ZSH, and you can see that it is ZSH is selected. So in order to just show you further, I need to do one more thing here. I'm going to use user mod for user modification -S for shell. I'm going to change it to bash, Ben bash for the user Wahid. And it's going to say you don't have sudo access. You need to just run it with sudo. So I'm going to run it with sudo. I provide the sudo access here. And now my shell has changed. So let's see if this command is showing ZSH still is showing, because echo $shells, $shell is doing that. But let's see, get end password, and then Wahid. And you can see now it is Ben bash. So echo $shell is still pointing to the older one because that environment variable dynamically did not change as I changed the user mode there. So if I just exit out of this one and then open a new shell, and then I say get end password Wahid ID-UN echo $shell. Notice that this is still ZSH, which is this environment variable has to be pointing to the Ben bash because we modified it. Let me just log out of the system, log in, and then see if that one is still are gonna say it or we need to do. So I'm gonna say log out first, because a lot of the etc profile and dot profiles stuff that runs sometimes sets it, and we can just look at it to see how it is happening. So I'm going to start it. I power it up, and I'm going to start it back. And this is starting it right now. I'm going to take the notification out. So it should come up here for the login, and then I click on the login, type in my password. Now the prompt is there. I just logged in, and now I'm going to say get end password Wahid ID, and then echo $shell and PS, and you can see everything changed because I logged out in my etc profile, and the tilde.vshrc. In this case, it actually run the bash rc. The bash rc set up my environment here. So when I did the echo $shell, now it is showing bash. Now I'm going to just do a user mode again, and this time, since it is Ben bash, as you can see here on this command, you can do this, or you could say run the ID-UN here, or you could do $. Many ways to run the same ID-UN as dynamically, so you don't have to type in hard code with the username here. If the username is root, this will just bring it for root. So let me show you that one. Sudo su dash, and then I become root here. That's the equivalent of get dash and get end password, and then a $ID-UN. In this case, when it runs, the output of ID-UN, which is root, it's going to pay pass, and then it says the root default shell is Ben bash. So $shell, you can see it is Ben bash, and echo $home is /root, and that's exactly as the directory that I am. And then here, since it's a bash, there's also etc profile here, and then also .bash rc. Sorry, clear screen. ls minus la, and then there's a .bash rc or not. Yes, there's a through C shell, and then bash profile and bash rc. I just had a typo here when I type it. I missed the A here. That's why it was not listing. So you have to be careful when you're typing sometimes, and read what you're typing. And I just sometimes have done these things forever, and then I just sometimes get a little bit too quick on it and make mistakes on the typo. Sorry about that. So here we are going to discuss the shells, and then we are on the ID. So clearing the screen, ID-UN, provide you that one, ID- group name, and -UN means user, and then N is just, so if I say -G for group, since I'm root, it's going to say group 0. And group and number, and user number is also 0. If I say grep root etc password, there's a couple of the user that has a similar user ID. One is operator and the other one is the main root account. So you can say the user ID is 0 and the group ID is also 0. And the home directory is /root and the owner is root, the shell is ben bash. So if I just go with get int password and I just type in root, it obviously give me that one, but I don't have to type in that. I could do backtick ID-UN, that will also give me the same thing. Or if I don't want to use the backtick, I could use the $, and then this, and then ID-UN, and that will also do the same thing. So we looked at that one for the shell. Now let's just modify user mode, and this time for the, we could do it for the root as a shell, or we could just do it with the other ones. I want to try it with root. So user mode, we just say user mode minus shell, and then ben ZSH for the user account root. Now notice that if I just say get int password, and then root, it shows that I just changed it to ZSH there. So if I just say PS, if I say ZSH, go to ZSH, PSH echo $shell. Now $shell is pointing to bash, which was previously there. Echo $sign is there. I need to just turn on the light. It is really dark in the room. I could barely see my keyboard. So let me pause the video for a second. So we can see the echo $sign is pointing to 2888, which is the ZSH shell. So at this time, I'm going to just say, yeah, let's just run some ZSH command here. Since my shell is currently pointing to ZSH, clear the screen. Yes, echo $sign is pointing to the ZSH process. So I could just say, let's just use a for statement here. I'm going to just say for I in sequence of 10, do, and then echo $I. Since I did not put the sequence 10, that is just not going to do much than just printing this. But if I just put the sequence of 10 in a backtick here to run the sequence 10, it's going to just do that 10. It's almost like running sequence 10 here, that will just give you that number. But if you want to do that one within a for statement to just write some meaningful word, and instead of just saying echo $word, $I, you could say something like number name is, and then you could just say the number is. Now it is a little bit more within the for statement, so you modify the sequence variable there. So in addition, for example, if I just do it instead of this, I could use the backtick. I did the backtick. If I use the $, kind of parameters, passing it as a subset, there you could do a subshell, $sequence 10, you could do this. And this number, it's not just only to do 10 numbers. Obviously, you can do as many as you want. So if you want 20 of them, you could do that. But you can also, with the sequence command, you can also run commands like, let me just go in here and say, I'm gonna do a $, and then say, start from 0, and then go increment by 5 and up to 20. And then let's see, Oh, I had to put a sequence here. I forgot the word sequence here. So you can see here when I clear this command here, and then I run the sequence command here from 0 to 20 with increment of 5, you just print that one. And you can also do this one, for example, start with 20 and then decrement by 5, go to 0. You could do that way. Or you could just say start with minus 20, going and then increment it by 5 going to 0. You could do minus 20, minus 15, 10, minus 5, and then 0. So the sequence command is really helpful. So if I just do sequence minus 25, 0, it will just generate those numbers. And if I do 200, obviously the numbers are bigger, but let's just do it with 50 of them, the decrement by 50, and then you can do that. And you can always just go the other way around. So from 0, 50 to let's say 500, and then I'm going to do this one to 100, so you can see it in one line. You can see that. And then this is a bigger number, 1000. You could get the number. So within the for statement, you could do a lot of statements. Obviously, the sequence itself is not going to just be as friendly with do this one with the steps of for statement, say for item and this sequence, and then you put this one in backtick. You could say this and say do, and then now say echo. If you just want to do some kind of computation, you could do on the fly with expression and other ones, as well as say if you want to do a printf statement on the language printf statement, you could do percentage %d, and then item, and then done. So notice that percentage %d for the mold there. So if I just change this one to a new line character for every one of them, then I just get that information here. And if I just want to change the number, do some computation, obviously, you could do that as well inside there. But let's just get back to the user mode. So I did get and password root, and then it is showing the ZSH, which is the shell that was not there originally. It was bin bash, and I just modified it with user mode. So if I exit out of this one, exit out of this, exit out of this, and then come back, and then I use the shell again to just open the shell, and here I say sudo dash, and then type in the password for root, and now I'm root, and then ID -un. It shows there get end password root. You can see it's a ZSH there by default. Echo $shell also show me Ben ZSH, so it's no longer bash. If I want to leave it that way, then I could do that. But since I'm on the root already, I want to show you another directory, which is /boot. That's the Linux kernel. When it starts, it needs this directory /boot, and then there's also grab2, clear screen /boot /grab2 is the grab configuration files. This grab.cfg configuration files, and menu and other ones are there, as well as on /boot you have the VM Linux, the rescue files, and then the initial RAM disk files. So this image file, you can see the one that is really huge size. You can just know that when your system boots, it loads the bootloader, the Linux kernel, the initial RAM file system, which is with a combination of VM Linux the image file that gets loaded at the time using the grab2 help menu or configuration menu. And once it comes out, you say uname-s, that is the system name, or uname kernel name, that also give you the Linux system. Uname-a will give you all, and uname-r will give you the revision or the kernel build. So we have Linux running, uname-o, the operating system, GNU Linux, uname-v for the version, symmetric multiprocessing. All these information are very helpful. Uname-help, it gives you all of them. Uname -m for machine type, uname -p for platforms, x86-64 and machine type is the same. Uname kernel name, which I typed in earlier, is similar to uname-s, which is Linux. And uname-o is the operating system GNU. So we know that it's on the /boot. When it comes in, if you do uname-r, it is the 5.14 version, the build, and that is 5.14 here on this initial RAM disk, and then all the images files. So this image file is showing 5.14.024. The way this revision or build is working, it is the major number is 5 here, the 5, and then the minor number is 14, and this is just the release date that was released at the time, and it is for x86-64 build. The EL92 is saying that it's Enterprise Linux 9 subversion is 2. So cat -n etc os-release give you all that information as well. You can see it's a 9.2, and it's a Rocky Linux 9, and it is somewhere there. It says Red Hat Enterprise Linux CentOS Fedora distribution, and it is a Rocky EL9 Enterprise Linux 9. So you can also get it from etc or Red Hat release. It says Rocky Linux Red Hat 9 point this. So if I clear my screen, say etc star release, you can see that we have the OS release, which was the bigger file that is actually a symbolic link to user lib os-release file. And then on the Rocky version is same thing as Red Hat -release, because it's a Rocky version. So I could say cat etc Rocky -release. That is sorry. Let me just cat etc Rocky -release. You have to type it correctly, and then this one is symbolic. Red Hat -release is symbolic link to Rocky. So when you type in Red Hat -release, it reads this file, which is right here, etc Rocky Linux. I hope that helped you understand the Linux kernel, as well as the boot configurations, and then the grab2, the images, everything. So when you start your system, it reads these ones and it loads it, and then there are other videos that I have. And if your system hangs, how to boot it from DVD, how to just correct the password, how to just do a lot of stuff. So for those details, please go subscribe to our channel, and you're welcome to just watch all of them and enjoy as much as you can. You know, for example, this video is a 4 hours long video. It says from 0 to hero. This is the entire Red Hat Linux 9. So if you don't know anything about Red Hat or Linux Enterprise 9, don't worry about it. It just, everything is on this video from 0 to hero. That's what I mean by we start from very basic of Linux, showing you the operating system and the version and the details, and then we go through basic commands first, then intermediate commands and advanced commands, and then show you some system administration, a lot of stuff. Similarly, on this other video that I built last time, I believe it's one of these videos. Let me just see right here. Rocky Linux. This is also full course. So if you are interested to just learn Red Hat, watch that video. If you want to learn Linux Rocky version, it is this video. This video is also about 3 hours something. So this all details are there from zero to hero again. Welcome to MyWebUniversity free education videos. I hope you enjoyed it, and please don't forget to subscribe. I really appreciate you. Take care. Bye-bye.